Welcome to a fascinating adventure into the beating heart of the technology that surrounds the world, electronics. It's the invisible science that animates the digital world, from the little gadgets in our pockets to the giant screens in our living rooms. But what is behind this technological magic? How can a piece of metal and silicon transform into such a powerful tool? On this exploratory journey, we will discover together how electronics work. We'll start from the basics, from the fundamental laws of physics that regulate the flow of electrons, up to how these principles are applied in devices such as smartphones, computers, and even cars. Let's get ready to reveal the secrets of resistors, capacitors, transistors, and integrated circuits. But don't worry, you don't need an engineering degree to follow us. We will guide you step by step in a simple and fun way. Fasten your seatbelts. Let's set off on this incredible journey into the universe of electronics. To understand electronics, we must start with the infinitely small, atoms. Imagine a tiny universe with electrons orbiting the nucleus like planets around the sun. When these electrons move, they create what we call electric current, the lifeblood of every electronic device. Now, let's enter the world of electronic components. Resistors, for example, are like valves that regulate the flow of water in a pipe, controlling the current that passes through them. Capacitors, on the other hand, work a bit like mini-batteries, storing electrical energy and then releasing it when necessary. But the real star of the show are transistors, microscopic switches that can turn electrical flow on or off, acting as the brains of the circuit. Now let's take a closer look at these three basic components that make up the vast world of electronics. These three elements are the pillars on which all electronic circuits are built, from the simplest to the most complex. But how are they facts, and how do they work? Resistors are small components designed to resist the passage of electric current, limiting the amount of it in a circuit. They are usually made of materials such as carbon, metal, or metal alloys. They have a cylindrical shape with metal wires at each end for connection to the circuit. Their resistance value, measured in ohms, is often indicated with colored bands on the body of the resistor. Capacitors are devices used to store energy in an electrostatic field. They consist of two conducting plates, separated by an insulating material called dielectric. When a voltage is applied, the plates accumulate electrical charge. Capacitors can be found in various shapes and sizes, and are crucial in many applications, such as voltage stabilization and filtering of signal waves. Transistors, the true heroes of modern electronics, work as switches or signal amplifiers. They are composed of semiconductors such as silicon, with regions treated to have different conduction properties, P and N regions. Transistors generally have three terminals: emitter, base, and collector. The current flowing through the base controls the current flowing from the emitter to the collector, allowing the transistor to act as a switch or amplifier in the circuit. Each component has its unique and indispensable role. Resistors control current, capacitors store and release energy, and transistors switch and amplify signals. Understanding these elements is like learning the alphabet before reading a book. They are the fundamental building blocks with which we can begin to build and understand the incredible world of electronics. These components are the fundamental building blocks of electronics. They join forces to create circuits, which are like complex road networks where electrons travel. But how do you go from a simple circuit to a computer or a smartphone? The answer lies in their incredible evolution, a story that begins in laboratories full of vacuum tubes and wires and extends to modern microchips. Have you ever opened a computer or smartphone? Inside them, you will find a small marvel of engineering, the integrated circuit or chip. These chips are miniature cities with millions, even billions of transistors working together in harmony. Chips are a story of continuous progress and innovation. It all started in the 1950s with the first circuits that housed just a few transistors on a small slab of silicon. From there, we got to chips containing billions of transistors, thanks to Moore's law, which predicted that the density of transistors in chips would continue to double about every 2 years thanks to technological progress. This evolution has had an extraordinary impact. From the first calculators that took up entire rooms, we have moved on to incredibly powerful portable devices. These chips have made everything from computers to cell phones, cars to video games possible. And their evolution continues, pushing the boundaries of what's possible with electronics. The computer, this machine that almost seems to think, has a fascinating history. Starting from the gigantic calculators of the 1940s, such as the ENIAC, which occupied entire rooms and used thousands of vacuum tubes, we arrived at modern laptops, tablets, and smartphones. At the heart of every computer is the CPU, the central processing unit. It is the brain of the computer, which runs programs and processes data. Then we have RAM, which acts like a temporary notebook for the CPU, and storage, like the hard drive or SSD, where data is kept long-term. Inside every computer, at the center of its computing power, lies the CPU or microprocessor. But what exactly does this little black box of power contain? The CPU is a miracle of microscopic engineering, made up of millions, sometimes billions of transistors. These transistors, miniaturized to near atomic levels, work together to perform computing operations. The same technology is also present inside cell phones. The advent of mobile phones and the telecommunications revolution have indeed transformed the way we communicate and connect. From bulky and expensive devices to sleek multifunctional smartphones, cell phones have come a long and amazing way. On this journey through electronics, we have explored where we come from and where we are going. We have seen how simple physical laws and tiny components have revolutionized our world. We have gone through the history of computers, cell phones, and looked at emerging technologies that they will shape our future. Electronics is an ever-evolving field, and there are still many fascinating stories to tell and discoveries to make together. So sign up, join our community, and let's continue this journey of discovery together. Thanks again for being with me. Until we meet again.